Hello, good day. I am Hoverth A Ramirez from Tanjay City, and I am a postgraduate of Negros Oriental State University, taking up Doctor in Philosophy in Mathematics Education. And today, I will be talking about replacement when running cost and value of money also changes with time. This is one of the topics that you're going to encounter in operations research, and I will be expounding this one to you. So allow me. In order for us to fully understand this one, it would be best if we're going to have an example. So here's our sample problem. The purchase price of a machine is 5,000 pesos and its running cost is 700 pesos for each of the first 5 years and increases by 200 pesos every subsequent year. If the discount rate is 10% per year, when should the machine be replaced? Assume that there is no salvage value. In solving problems such as this one, it would be easier if you're going to make use of the Excel. So let's go. So here's our Excel. The first thing that you're going to do is to list down all the given in the problem. So we have our purchase cost, which is 5,000 pesos. Our salvage value equal to 0. Remember that we assume that there is no salvage value. That is why it is equal to 0. Next, we have our discount rate, 10%. Then our running cost, 700 pesos. Next up is we're going to make 9 columns. So for the first column, we have our year of service. The second one is for the depreciation cost. The third is for your running cost. The fourth is for the discount factor, which is 10%. The fifth column is for the discount running cost. We have your 3 times 4. I will be explaining later on what this one means. Then moving on to the sixth, we have our cumulative discounted running cost. The seventh is for the total cost. Just like on the fifth column, 3 times 4, this 2 plus 6 in column 7 will be discussed later on. Then we have our 8th column, cumulative discount factor. Then the 9th one is for the weighted average annual cost. We have here 7 divided by 8. Each column will be discussed thoroughly as we go along in this discussion. So let us start with the first column, year of service. So let us number this one 1 to 5 since we are mentioning 5 years in the problem. So we have 1 to 5, or first year down to the 5th year of service. Then let us move now to your second column, which is the depreciation cost. There's a formula in order for you to get your depreciation cost. It is your purchase cost minus your salvage value. And since our salvage value is equal to 0, so we have 5,000 minus 0 is still 5,000. So from year of service 1 or from the first year of service down to the 5th year, your depreciation cost would always be 5,000 pesos. Okay? Now let us move to the third column, which is the running cost. Remember that in the problem, it is stated that 700 pesos for each of the first 5 years. Your running cost is 700 pesos. Emphasis on for each of the first 5 years. Therefore, from year 1 down to the year 5, your running cost would always be 700 pesos. It will neither increase nor decrease. Okay? Now, moving on to the fourth, we have our discount factor, which is 10%. We have a formula on this one. So, formula for discount factor. The discount rate of money is 0.1. Remember that it is 10%. We just have to convert that one into decimal, so we have 0.1. Now, for our formula, our discount factor is equal to your V raised to the power of R minus 1, where our R here represent your year, the year of service. Then our V here represents the value. So our V here is equal to 1 over 1 plus I, and our I here represents your rate of discount, which is 0.1. So we just have to substitute 0.1 in I, so we have 1 over 1 plus 0.1, and it will become 1 over 1.1. Solving this one, our V now is equal to 0.9091. Now, since we have already solved the value of our V, then we have also the value of our R. Let us now try to fill in these blank spaces. Let us start with the first row for the year of service 1. So again, our formula for V is equal to our formula for our discount factor is equal to your V. So let's try to click this one. Then don't forget to enclose this one in parentheses. Okay, then let us try to raise this one to the power of our R minus 1. Again, our R represents the year of service. So let's try to click this 1 first. 1, then minus 1. Then don't forget to enclose this one in parentheses also. Then click. So we have our 1 here. Now, so that it would be easier for you to fill in these remaining spaces here, you could just drag this one down. But before doing that one, let's try to click this one again. You have to put a $sign before E and also before 3. The reason for this one is that, so that when you try to drag this one down, this one will remain constant. So let's try to click this one. So see, E3, still 0.9091. And as you can see, it's already in A row 11. Since we've moved now on the second year. Then in the third one, it's A12, A row 12. Still making use of this one. So that's it. That is just how you could do this one. So that's for the discount factor. Moving on to the fifth column, which is the discount running cost. Now, as you can see, we have here 3 times 4. So 3 and 4 here represent the label of each column. So 3 refers to the third column, while 4 to the fourth column. So 3 times 4, which means that what's in column 3 will be multiplied by what's in column 4. So we just have to do this one as equal sign, our first row 700 under third column multiplied by 1 under the fourth column. Then that's it. Let's try to put this one to center. So we just have to drag this one. Okay, easy as that. Okay, now let's proceed to the sixth one. We have cumulative discounted running cost. When we say cumulative, increasing. So discounted running cost. We have our discount running cost here. So all you have to do is just copy this one first. Okay, then click this one. So which means to say that as we move down, the value of each value under column 6 will be increasing. So this means that we're going to add 7. So first 700. Then the second row is we're going to add 700 and 636.37. Then as we move this one, the total of this one will be added to the next, and so on and so forth. So we have our 700 plus this one. It will become 1,336.37 pesos. Yes, and when we move to the third one, this 1,336.37 will be added to this one. So to do that one without hassle, let's just try to drag this one down. Then you have your column 6 filled with values already. Okay, now next, let's go to the seventh column. Before that, let's try to make this one. Let's place this one at the center. So let's move now to the seventh column, which is the total cost. So we have 2 plus 6. Again, 2 and 6 here represent the label of each column. So let's do that one. So 2, first row, 5,000 plus 700. Then drag this one down. Okay, let's put that, place that on the center. Yes, just a piece of cake. Then we have the eighth one. We have our cumulative discount factor. So again, cumulative, it will be increasing. Discount factor, we have the fourth one. So just like what we did on the sixth column, first is we're gonna start with the first one, then this one. So moving on to the second, the first one will be added to the second one, which is this one. Then let's just drag this one down. Okay, so we have now our cumulative discount factor. Then the last one is the weighted average annual cost, which is, you have to get this one, you have to get your seventh column be divided by your eighth column. So we have the first one, 5,700 divided by the first one and eighth column, which is 1. Then let's drag this one down. Let's place this one in the center as well as this one. So there you have it. We have completed now our table. See, it's just easy. Let us go back to the problem. Remember that it is stated here that our running cost is 700 pesos for each of the first 5 years, and it will increase by 200 pesos every subsequent year. Let's go back now on our table and let us try to continue solving it. Let's continue this one. So we stopped at the 5th year, so let us try to continue. Let's go to the 6th one. Then okay, let's try to delete this one first. So our depreciation cost would remain 5,000 pesos because again, remember, our depreciation cost is equal to our purchase cost minus our salvage value. And since our salvage value is equal to 0, so it would still be 5,000 pesos. Then for our running cost, remember, it will increase by 200 pesos after the 5th year. So let's try to add 200 to this one. Then it would become 900 pesos. Okay, so let's continue. Now for our discount factor, again, let's just try to drag this one down so that it would be easier for us. Then same with this one, and let's try to do that one with the rest of the columns. Now as you can see, in the 5th column we have 1,899. Moving to the 6th year, our weighted average annual cost is 1,769. As you can see, it is decreasing. So let us try to look. Let's going to continue if this column will continue to decrease. So let's move to the 7th one. Okay, then same, still 5,000. This one, so it's just a piece of cake. All you have to do is just drag this one down. So by the way, in the running cost, our 900 pesos will be added by 200, so it will become 1,100. Okay, so let's continue doing this one. Okay, and this one. So it still decreases, but the value still decreases. The weighted average annual cost is still decreasing. So let's proceed. Let's continue. Why don't we go with the 8th and the 9th one simultaneously? Let us try to solve it simultaneously. Okay, by the way, let's try to delete this one first. Then again, it will be the same. Then for the running cost, 1,100 plus 200 is 1,300 plus 200, that will become 1,500. Then dragging this one down, all of these, we have okay, let's try to look. Still, it is decreasing. Now, let us proceed. Let's still continue. The 10th one. So, still 5,000. Our 1,500 added by 200, it become 1,700. Okay, let us continue doing this one. See, it's just easy. You don't really have to do it manually, thanks to Excel. We have 1,655. Now, in this case, in the 10th year, our weighted average annual cost increases from 1,652 point something, we are now on 1,655. Now, as you can see, in the 10th year, our weighted average annual cost increases from 1,652 point something, we are now on 1,655. If you're going to look at all the values under the 9th column, this 1,652.01 is the minimum value. And this 1,652 point something occurs in the 9th year. So our 9th year is the optimum replacement period of your machine. Okay? So again, the lowest value here, the minimum value is 1,652.01, and it occurs on the 9th year of your 9th year. So our 9th year is the optimum replacement period of your machine. So again, your 9th year of service is the optimum replacement period of the machine. Now let us try to check our replacement policy with this solution. So a particular transaction is satisfied, if a particular transaction is satisfied, then you can get your asset replaced at the end of the period. So this is our replacement policy. This is the condition. Your current year weighted average annual cost should be less than the running cost for the next year. Now let us check our solution. On the ninth year, our weighted average annual cost is 1,652.01 pesos, and the running cost for the next year is 1,700 pesos. Obviously, this one is less than 1,700. Therefore, at the end of your ninth year of service period, you can get your machine replaced.